Good day, welcome to the big day. It's time to stick these in these. As you may have guessed, these are the CPU boards for the PDP11 04 and 34. This is the single board that this 04 needs, an M7263 I believe, and the 04 with its 34 with its memory management requires two boards, the 8265 and 8266. Now, in keeping with my aim to always test things with the smallest possible increments, I'm going to do the 04 first because it only has one board, and then we'll try the 34. I just want to get it to execute a very simple program and then try the same thing on the 34 just to confirm that these things basically work. And hopefully this will be a one-part video without any follow-up repair videos. Okay, let's get to it. Now, I've transferred the only good M9302 that I have from the 1134 into the 04 and checked that the repaired M7859 console still works, that the repair hasn't come unstuck. And now I've put in one of the known good M7847 memory boards. I'll just make sure that that still works in, because that was only been tested in the 34, so I'll just make sure that I can just read and write a couple of locations in this machine, and then we'll try plugging in the CPU. So, power on, computer on. Now this is not as noisy as the 34, I don't think. I think it's got crappier fans. I have bought a couple more fans, which I'll probably transplant into the 34. And this one I think is pretty much quieter than the other. We'll know shortly. Anyway, switch register test. 1, 2, 3, 4, 5, 6. Load switch register. 777. Oops, that's too many 7. 777. 570. Load address. Examine. Back comes the number. Okay. Location north. Load address. 1, 2, 3, 4, 5, 6. Deposit, 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 deposit. 11111. Deposit, 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 deposit. 2222222. Deposit, 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 deposit. Clear. Load address and examine. Here's our 1, 2, 3, 4, 5, 6s. Keep examining. We should hit the 1s. There we go. And then the 2s. Yep. So the top bit of the 2 was off because there is no, you can't have a 2 in the top position. That would be it. One more bit than we've got, one more bit than 16, and then all bits on for the rest of memory. So memory's looking good, time to stick in the CPU. Now I've put in the CPU board and I took a break, and when I came back and I was about to power it on, just out of the corner of my eye I noticed something, and before I even noticed this thing, I planned on mentioning that I'm not confident about this thing working because everything else on this 1104 had a fault. There was a bad capacitor in the power supply and a loose connection, I think. The keypad down here, there was a broken wire going to the console board along the front here. The console interface had two bad chips. That's the M7859 down there. The terminator card had a hairline crack and a trace, and later a chip overheated. Maybe even one of the dud memory boards I've got came out of here. So there could be a memory board added to that list of faults. And I also mentioned somewhere along the way that I think that this had two memory boards in it, and the PDP11 34 had only one memory board, but I think it's the other way around. I think this one only had one. Anyway, the thing I noticed is, I just glanced at these terminals, the pins on these ALUs, these 74181 ALU chips, are pretty black, and they look like there was guns joining them together. I took a closer look, and yeah, some of these pins have got some muck joining them together, and then I see a bit of corrosion here, and in fact all the pins on that chip there look a bit rotten. So I don't know, I'm a bit embarrassed I didn't notice all this before, but some of the reason this machine has so much trouble was because it was stored in a shed, and when I got a hold of it, and it had bird shit on it and maybe a bit of leaking rainwater getting onto it. So it's not surprising that there are issues in the thing. So I'm not going to power it on while it's like that. I'm going to, in the cold light of day tomorrow, take it out and have a very good look at it. I'll try and zoom in on those faults, and I've got a torch here because the lighting here is not brilliant, but let's try and zoom in. I won't try and zoom in any further than that, put a bit more light on it, but seems to be some guns joining the pins here, and you can see how terrible that is. So yeah, nothing else looks quite so bad on the board, but yeah, around there it's pretty terrible, and there might even be corroded traces on the board, so could be a bit of work on this board, but bodge wires won't be a new thing to it. It looks like it's got quite a few factory bodge wires. So I'll look at that in the morning. I could just push this aside and do the 34, but no, I'll have a look at this first, and maybe I'll try and get some deoxit. Hideously expensive stuff it is, but maybe it will be helpful on that. We'll see how much luck I have tomorrow with some cleaning substances and a toothbrush. So we'll see what happens. So I lashed out and bought some deoxit. Yeah, very expensive stuff, and a lot of cleaning of toothbrush and those things. And you can see along here that black's gone on a lot of places, and most of that corrosion is gone. And yes, it looks like there's a crack that's been corroded through, or so I thought. But had a closer look. Don't know how well this will show up. I should have taken a better before picture, but I'll describe what I've discovered in a moment. But it looks like there's what's that better? Not sure how well this is showing up on video, but it looks like there's a track across there that's been corroded away. But maybe not. And I'll show you why. So this is the best image I have of this board before I tried cleaning it up. You can see the dirt on these pins, the blackness. It looks like, this is what I first noticed, looks like it's even shorted together there, but I think a lot of that is the body of this chip seems to stick out pretty close to the pin, so it might be mostly that with a bit of corrosion on top of it. And here's the worst part, this chip, and it looks like there's a trace there that's been corroded away. And if we look at that after cleaning it up, you can see that blackness on those pins is gone compared to all that. So considerable improvement. The deoxit does something at least. So there's our very badly corroded area cleaned up. It's still not perfect. There's where it looks like there's a trace that's been corroded away. But when I look closer, see that? I think it might be that there. It looks like an actual nick in the fiberglass, like there's a scratch there, as if it was a deliberate cut rather than corrosion. So I tried to buzz it out with a multimeter as well as I could find the end points of the cut, traced out where they go to, and then looked at it on the schematic and came up with this. So there's the cut, that yellow line. This is what it looks like. There was a trace that ran from E37 pin 5 and 6 across there to E20 pin 4, and there's E20 pin 4 going across to E37 pin 5 and 6. So it looks like there was a wire going straight down there, and this is the cut. And what they've done, you see this bodge wire here, which I've paralleled with the blue. It goes right across to the other side of the board to E135 pin 9, and there's E135 pin 9 there. So there's that trace I just followed. The output of that chip up here
comes back along the other blue line to E62 pin 9. Yeah, there it is there. E62 pin 9, which via original printed circuit connects to 5 and 6 on E37, which is roughly where this line goes. So it looks like this used to connect there. They didn't like it. They cut it there and joined that to here to go through that gate, come back to here, which connects to the same point as where that used to go. See that there is this wire here. So that pin 9 up here is effectively the other end of this broken trace. So I think that's what's been done. There's quite a few bodges. Look at it over here on the side of the board. There's bodge wires everywhere, and unsurprisingly, some of the bodging would have involved trace cutting, and I think that's an example of it. It just unfortunately happened to be right where the corrosion was too. That's my theory. Let's see how it pans out. So given that that broken trace is almost certainly a factory modification rather than just a corroded trace, that indicates that the corrosion there is not as serious as I first feared, and maybe with the clean up it's okay. I mean, this chip is, yeah, the pins on it are pretty ill, and maybe really that should be pulled out and the underneath checked out as well, but I think it's going to be okay to power on. So here we go. Let's see if there's any smoke. So power on there, power on here, watch out for smoke. Done. That's always a good sign, isn't it? No smoke when you turn on your computer. So looking at the console, the run light's on. Does control alt stop it? Did something, didn't it? Bus error, control alt. Let's see if it's done anything to upset the just a normal console operation. Let's just try the old switch register test. Switch register 777570. Load address, examine. Oops. And maybe that run light's got something to do with it. Try that once more. 1, 2, 3, 4, 5, 6. Load switch register. 777570. Examine that location. No. Power off and on again. Try that once more. 1, 2, 3, 4, 5, 6. Load switch register. I'll try clear this time. 777570. Load address. Power just went off. I hope that wasn't because of my computer. It looks like it might be the neighbourhood, but okay, I guess that puts an end to that. I'll turn the power off on this computer anyway, so I'll report back to you when the lights are back on. So there was a very long fade in to compensate for the very rapid fade in from the previous segment. I went for a walk for about half an hour around the neighbourhood, and quite a widespread blackout. Seems my street was on the edge of it, but in the other direction it went for I don't know how far, so at least a couple of thousand properties were affected, but after about 25 minutes it came back on. So where was I? Run light on. While I was reviewing the previous video, it occurred to me that maybe that's because I haven't got the bus grant continuity cards inserted, and that vaguely rings a bell that the run light will stay on because of it. So I did some research, and it said that the non-processor grant has to be, that chain has to be continuous. So I'm a bit confused. I mean, I'm new to this stuff, even though I've had them for years. I'm certainly no expert on it. I'm learning as I go. So I've got to do some more research on that, but I've got a bunch of these grant continuity cards that go in slot C. I'll tip this up. These guys go in slot A, B, C there,
Now I've got what, 1, 2, 3, 4, 5, 6 empty slots there. Yeah, so 6 empty slots. So these propagate the bus grant from one slot to another, but what happens at the end? Is it wired to return it or something? As I say, I've got to do some research. I've also got this other one which goes into C and D, and it also does the NPG signal, which one of the things I saw said was responsible for the run light being on, and that's apparently normally wired on the back plane, and you cut it when you're going to have a DMA device. So again, what happens at the end? And I've only got one of these and there's 6 empty slots, so presumably, hopefully, many of them are already wired through. And I believe I looked at my notes, my drawings from long ago, and although I said before that this one only had 2 M7847 memory cards, I believe it actually did have 2, and the 34 had 2, so there was 4 of them, but I've only been mucking around with 3, so I'm not sure what's going on there. Those notes also indicated that in the last slot was a, what is it, M7856, just off the top of my head, for the floppy disk controller. Now that might, I would expect, might use DMA, so it could be involved with this non-processor grant DMA stuff. Obviously I'm a bit confused, I've got quite a bit of research to do, but that's the state of play at the moment. So there is still hope for this CPU. It might just be a matter of installing these things. The other thing that's a bit confusing, so this is obviously how the grant cards should fit in those 2 slots. So you can see the grant signals, the normal ones, are on this side, so this connector should go in this way with the, but it sits at an angle. If you put it in the other way, which is wrong, it sits correct, which is a bit annoying. The right way round, the things sit in an angle. Oh well. Well, since that last segment, I've done a lot of research on why these bus grant cards are necessary, even though there's nothing down here to receive the signal that they allow to be propagated. And then I had to check that the NPR signal, which this version of the grant card, which is like one of those plus a loop here, check that that signal was wired on the back plane, because these aren't, that's why you need those, but these, the NPG signal should be routed on the back plane. Anyway, trying to buzz it out, I noticed that there's a broken connector here. One of the bits of Bakelite between pins is broken off, and it seems to have gone in there because a card can't be inserted in there. That's going to be a mongrel to try and fix. I think I'm going to have to take the back plane out and God knows what to get in there and try and fix that. Might even end up destroying that row, so that, or at least part of that row, so that only certain devices, or maybe no devices, can be plugged into that slot. We'll have to see. I'll ask the experts for some guidance on that, but for the moment I think this PDP1104 is too much trouble to get working right now. Anyway, that's obviously a big job, and so I think I'll just move on to the 1134, try sticking the CPU in that, and we'll see what happens there. It'd be nice to get one running PDP11 in this video, wouldn't it? Alright, so I'll be back with this 1134. Now I was just about to give up on this 1134 because I found a broken connector there. I'll try and zoom in on it. This bit of Bakelite that separates the pins and retains them backwards, back against the sides of the connector, is broken, and I managed to fish out the little bit of Bakelite that was blocking your card getting in. Trouble now is that these two pins, without anything to restrain them, the two sides come together and touch for the first three signals, and two of them don't matter, but this one is minus 15 volts. One side is minus 15 volts, the other one is the non-processor grant out signal, which is better than in. So I think what I'm going to have to do is just stick a bit of blank PCB in that slot to keep the pins apart, and just never use that slot, or put a card in that slot and be very, very careful every time it's taken in or out. We shall see. So yeah, hope is not lost. We might be able to persevere with this thing. So how ridiculously ambitious it was of me to think that I could do one video and get two PDP11s working. Be struggling to get one going. Right, I've managed to convince myself that the NPG signal going from CA1 to CB1 on all these connectors is making it. That broken Bakelite there, I've stuck a piece of blank circuit board in there to keep the pins apart, but I've just realised that if that NPG signal does run back to the processor, and this connector was connecting the out to minus 15 volts, then that means minus 15 volts was going into the non-processor grant output from the CPU, which can't have been good. But let's see what happens. All those are in. The NPG daisy chain seems complete. We've got the correct terminator card with this SAC turnaround logic, and let's just turn it on and see what happens. Alright. That was on already. Run light's still on. Control halt. Doesn't get rid of it. So we've still got that problem. Run light on. Alright. Time to give up on this 04, I think, and play with the 34, because this thing has had problems every step of the way. Why should it stop now? I'm just not having a good run here today. I just plugged in the IEC cable into the power supply of the 1134 and then plugged that into a power board, and boom, nastiness, sparks, and you know what? Yeah, not sure what's going on there, so that's a worry. So what I'm going to do is run it through a dummy load, through a current limiter rather. So if there is a short circuit, it'll just turn on the lamps. So let's see what happens. Right, so the power supplies are dead short now. Bugger. The input to that power supply is turned into a dead short. That isn't even with the circuit breaker here on. So, bloody hell. I don't need this shit. What could be wrong in there? Alright, so this video gets marked as fail. I'm going to do something else for a while. I'm sick of these damn things. I'm going to put them aside. I'll probably pull that power supply out. I want to replace the fans in there anyway, and this wire, this cable should be on the other side of that rail, so that's got to come out in any case, and we'll see if I can find out why it's turned into a short circuit. Mongrel. Alright, very disappointing video. I hope you enjoyed it just the same. Catch you later.